Hello and welcome to the World War Lab channel. Today we're stepping back into a moment when industry, urgency, and imagination collided, and when the future of modern production was quietly being reshaped on the American coastline. On November 12, 1942, in Richmond, California, a fully completed cargo vessel, 441 feet in length and weighing nearly 28.5 million pounds, stood poised to slide into San Francisco Bay through the massive gates of Permanente Metals Corporation, Yard Number 2. What made this moment extraordinary was not just the size of the ship, but the speed of its creation. The vessel had been assembled in only 4 days, 15 hours and 29 minutes. In traditional shipyards, master builders had spent 6 to 8 months constructing ships of comparable size, a practice that had remained largely unchanged since before the American Revolution. And yet, here stood a complete Liberty ship, ready for active service. More than 1,000 workers stepped back from the hull of the SSRobertEPerry. They were not seasoned shipwrights or lifelong maritime craftsmen. They were former secretaries, farmers, housewives, and general laborers who had learned welding techniques just weeks earlier. Around them gathered a crowd of officials, journalists, and rival shipyard owners, all witnessing a moment that would ignite a deep and lasting transformation in industrial production. This was the birth of a systematic revolution in American manufacturing, a revolution that would echo for decades to come. The true mathematics of Allied victory were being written not in battlefield strategies, but in production statistics that shattered every assumption experts held about shipbuilding limits, construction timelines, and the very boundaries of industrial possibility. This transformation had begun on December 27, 1940, when Henry J. Kaiser signed his first shipbuilding contract. Kaiser was a man who had never built a ship, never managed a shipyard, and had spent his career moving earth and pouring concrete for massive dam projects across the American West. Yet at 58 years old, this construction magnate stood before the United States Maritime Commission and promised that he would build 30 cargo vessels for the British government within 2 years. Traditional shipbuilders dismissed him as a naive opportunist. Bath Iron Works, one of America's oldest and most respected shipyards, reluctantly agreed to partner with Kaiser, believing their experience would compensate for his ignorance. What none of them realized was that Kaiser's complete lack of shipbuilding experience would become his greatest strength. Among those watching closely was William Francis Gibbs, America's most respected naval architect. His firm, Gibbs & Cox, had created the Liberty ship designs based on British plans. Gibbs had designed more ships than Kaiser had probably ever seen. The journey from doubt to revolution began in the planning offices of Todd Shipyards in New York. As Kaiser and his engineers examined traditional shipbuilding procedures in early 1941, they immediately understood that conventional methods could never meet the demands of wartime production. Kaiser's chief engineer, Clay Bedford, had visited a Ford Motor Company assembly line in Detroit just weeks earlier. He watched automobile chassis move steadily down production lines as workers installed prefabricated components at each station. Bedford returned to California, convinced that ships could be built in the same way. Traditional shipbuilders found comparison ridiculous, even insulting. The first true shock came with Kaiser's proposal to eliminate riveting entirely. Traditional ship construction relied on rivets, heated metal pins hammered through overlapping steel plates to hold hull sections together. Even a perfectly coordinated and highly skilled riveting crew could install perhaps 100 rivets per day. A single Liberty ship, when built conventionally, required close to 1 million rivets. Kaiser proposed replacing this process with electric arc welding, a technique he had mastered while building pipelines across the American West. Vice Admiral Emory Land, chairman of the United States Maritime Commission, examined Kaiser's proposal with deep skepticism. His private correspondence, preserved in the National Archives, captured the maritime establishment's fear. Welding had never been proven reliable for hull construction at this scale. The British Navy forbade welding on warship hulls. Kaiser, in their view, was proposing that America gamble its entire supply chain on an untested technology. Yet Land also understood the desperation of the situation. German U-boats and surface raiders were sinking Allied shipping faster than traditional shipyards could replace it. In 1941 alone, approximately 3.6 million tons of Allied shipping would be lost to the ocean from all causes. Britain was literally starving. Using conventional methods, American shipyards require an average of 230 days to build a single cargo vessel. At that pace, the Allies would lose the Battle of the Atlantic long before American industry could respond. Approving Kaiser's contract was not an act of confidence. It was an act of necessity. The Richmond shipyard rose from empty mudflats between January and December of 1941. Kaiser construction crews, experienced in building dams and highways, erected a facility that horrified traditional maritime engineers. Instead of the massive gantry cranes and long, narrow building ways that defined established shipyards, Richmond was laid out like an automobile assembly plant. Vast open areas for prefabrication surrounded 7 parallel building ways. Railroad tracks crisscrossed the facility, designed to move enormous steel sections weighing up to 150 tons. Overhead cranes capable of lifting entire ship sections stood every 100 feet. John Riley, chief naval architect for Bethlehem Steel Corporation and a 30-year veteran of shipbuilding, visited the Richmond Yard in May 1941. His inspection report, marked confidential at the time, was filled with both criticism and reluctant admiration. He wrote that Kaiser had violated every principle of efficient shipyard layout he had learned in 3 decades. The prefabrication areas were too large. The crane capacity was absurdly excessive. The building ways were too short. Yet he admitted that the facility was designed precisely for what Kaiser claimed: rapid assembly of prefabricated ship sections. The arrival of workers marked the next phase of revolutionary change. Traditional shipyards recruited from long-established maritime communities where skills were passed from father to son across generations. Kaiser placed advertisements in newspapers across the country, offering wages 20% higher than standard industrial rates and promising to train anyone willing to work. The first groups arrived in Richmond in August 1941. The simplification of complex tasks into repeated, simple operations was borrowed directly from the assembly line. The application of assembly line manufacturing principles proved devastatingly effective. By October 1941, Kaiser employed more than 10,000 workers in Richmond, yet fewer than 200 of them had any previous maritime experience. In traditional shipyards, welders spent 4 years as apprentices, learning a broad range of complex skills. Kaiser's instructor, however, taught only specific techniques for specific tasks, and this training took roughly 2 weeks. Workers did not need to know how to weld every type of joint. They only needed to know how to weld the vertical seams on bulkheads, or the horizontal seams on deck plates, or the curved seams along hull sections, tasks they would repeat over and over again. As workers gained experience through late 1941 and early 1942, something unexpected began to happen. The construction time for Liberty ships started to fall at an astonishing rate. Kaiser's first Liberty ship took 197 days to build and deliver. The second required 169 days. The fifth took 128 days. Ship number 10 required only 97 days. By the spring of 1942, the Richmond yards were completing Liberty ships in an average of 70 days. Traditional shipyards watched with growing alarm as this largely untrained workforce reached and then matched the production speed of their own highly skilled and experienced crews. The prefabrication approach that had been dismissed as unrealistic was proving its extraordinary power. Instead of building ships sequentially from keel to deck, Kaiser's yards fabricated entire sections at the same time across the facility. While one crew assembled a bow section in prefabrication area, other crews were building stern sections, deck houses, engine rooms, and bulkheads in parallel. Once a section was complete, massive cranes lifted it onto the building ways, where welding crews joined it to the growing hull. Albert Wooding, production supervisor at Richmond Yard No. 2, explained the efficiency in a 1943 interview with Fortune magazine. In traditional shipbuilding, he said, you cannot install the engine until the engine room is built, and you cannot build the engine room until hull is finished. Everything happens in sequence. Kaiser's system allowed parallel production. While one crew welded hull plates, another crew assembled the engine in a separate area. When both were ready, the completed engine was lowered directly into the completed engine room and welded into place. Tasks that had once required weeks were now completed in hours. The statistics of parallel production revealed levels of efficiency that seemed impossible to traditional builders. In a conventional shipyard, 50 workers might struggle for 3 weeks to install an engine inside the cramped space of a partially finished engine room. Under Kaiser's prefabrication system, 200 workers assembled a complete engine and its mounting structure in an open workshop over 5 days, and then cranes positioned the entire assembly into the ship in a single 8-hour operation. Even more disturbing to traditional maritime authorities was Kaiser's casual rejection of centuries-old shipbuilding practices. Ships had always been constructed from highly detailed blueprints that specified every measurement and every method. Kaiser used simplified drawings that gave basic dimensions but left many details to the judgment of workers on the floor. Traditional builders called this recklessness. Kaiser called it flexibility. Vice Admiral Howard Vickery, vice chairman of the Maritime Commission and a career naval officer, initially fought fiercely against Kaiser's simplified specifications. His transformation from critic to supporter, recorded in commission meeting minutes, demonstrated how results could overpower theory. In January 1942, he stated that he opposed Kaiser's request to reduce drawing specifications, insisting that ships were not automobiles and that maritime construction demanded precision. But by March, Kaiser's yards were outproducing traditional contractors by 40%. By June, the gap had widened to 70%. Vickery eventually admitted that perfection was the enemy of sufficiency. Kaiser's ships were not beautiful, but they were adequate, and adequate ships delivered far more cargo than perfect ships that were still under construction. As construction speeds increased through the spring and summer of 1942, competition developed among Kaiser's 7 shipyards across California, Oregon, and Washington. His son, Edgar Kaiser, who served as vice president and general manager overseeing all Kaiser shipyards with special attention to the 3 facilities in Pacific Northwest, managed the Oregon Shipbuilding Corporation in Portland. Clay Bedford continued to oversee the Richmond yards in California. Both men were ambitious and driven, and an informal rivalry emerged between them to see which facility could build ships faster. The race between Richmond and Portland became a public spectacle by the fall of 1942. Newspapers published progress updates like sports scores. Records were broken again and again until the Oregon Shipbuilding Corporation completed the Joseph N. Teal in only 10 days in September 1942. Eventually, Vice Admiral Vickery ordered the speed competitions to stop, calling them stunt demonstrations that distracted from real production goals. But by then, the competition had achieved its purpose. Workers across all 7 yards now believed that extraordinary speed was not just possible, but expected. November 1942 brought the ultimate test. Vice Admiral Emery Land visited Richmond to inspect production and casually remarked to journalists that Liberty ship construction had improved remarkably, but that the recent speed record still paled in comparison to what mass production had achieved in other industries. Clay Bedford overheard the comment and took it as a challenge. He proposed to Vice Admiral Land that Richmond Yard No. 2 would attempt to build a complete Liberty ship from keel laying to launch in less than 10 days, cutting the Joseph N. Teal's record in half. Land was skeptical but intrigued and approved the attempt, provided it did not disrupt normal production schedules. Bedford selected the 47th hull to be built at Yard No. 2 for the record attempt. The ship will be named the SSRobertEPerry in honor of the Arctic explorer. Beginning on Sunday, November 8th, at 1 minute past midnight, More than 1,000 workers operating in carefully coordinated shifts would attempt something never before achieved in maritime history. The prefabrication strategy reached its ultimate expression during the pier construction phase. Every major component of the ship had already been built, inspected, and staged before the keel ever touched the building way. The bow section, composed of more than 50 individual pieces, had been completely welded and fully equipped with anchor hardware, chains, and fittings. The bow section had been finished with its lockers installed, along with the forward crew quarters, even before assembly officially began. The stern section already contained completed steering gear, the propeller shaft, and the aft crew living spaces. 4 complete cargo holds stood ready, each a massive rectangular steel structure designed to be lifted directly into position. The engine, a 140-ton triple-expansion steam power plant built by the Joshua Hendy Iron Works in Sunnyvale, had been mounted on its foundation frame and fully tested before it ever left the factory, where conventional shipyards work from keel to deck over the course of many months. Kaiser's yards assembled what was nearly a complete ship from prefabricated sections in just days. 4 days into construction, the hull was already finished. The engine was installed, the deck houses were in place, the cargo holds were secured, and the steering gear was mounted. On Thursday, November 12th, at 3:30 p.m., only 4 days, 15 hours, and 29 minutes after the keel first touched the building way, the SS Robert E. Perry slid down the launching rails and into San Francisco Bay. The ship was delivered for service on November 15th, setting another astonishing record of just 7 days, 14 hours, and 32 minutes from keel laying to full delivery. The crowd that gathered to witness the launch included maritime officials, military officers, rival shipyard owners, and journalists from across the United States. Many had arrived expecting either a failure or a compromised vessel that looked complete on the outside but lacked true functionality. What they saw instead was a fully operational ship that required only minor final fitting before entering active service. Vice Admiral Emery Land, who was present for the launch, made brief remarks that were captured by newsreel cameras. His words reflected the forced acceptance by the maritime establishment that an era had ended. He stated that 6 months earlier, he would have called such an achievement impossible. Traditional shipbuilding wisdom, accumulated over 3,000 years, insisted that a proper ship could not be built in 5 days. Henry Kaiser, he admitted, had made that traditional wisdom obsolete. From that moment forward, the United States Maritime Commission would require all contracted shipyards to adopt these methods. The psychological impact on traditional shipbuilders was immediate and profound. The same yards that had dismissed Kaiser as an ignorant outsider only 18 months earlier now began sending their engineers to Richmond to study his methods. The president of New York Shipbuilding Corporation, one of America's oldest and most prestigious shipyards, visited Richmond in December 1942. His confidential report to his board of directors revealed a complete collapse of faith in traditional approaches. He wrote that Kaiser had achieved what the industry had long considered impossible by refusing to accept its limitations. Kaiser had treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where others had pursued perfection. He standardized where others customized. He trained large numbers of unskilled workers where others relied on generational expertise. The result was ships built in 1/10 the time and at roughly 2/3 the cost. The conclusion was unavoidable. The industry must either adopt Kaiser's methods or accept irrelevance. By early 1943, Kaiser's influence had transformed American maritime production. 18 shipyards across the country were now building Liberty ships using prefabrication and welding. Average construction time had fallen from the original 230 days to just 42 days by mid-1943. The United States was launching 3 Liberty ships every single day, producing more shipping tonnage than German submarines could possibly sink. Yet perhaps the most devastating challenge to traditional maritime authority came not from speed or volume, but from the composition of Kaiser's workforce. Tens of thousands of women, minorities, and previously untrained workers had built these ships. Their success represented a direct refutation of the old guild system that had dominated shipbuilding for centuries. At peak production in 1944, Kaiser's 7 yards employed approximately 196,000 workers. More than 40,000 of them were women, an extraordinary proportion for a heavy industry at the time. By mid-1944, women made up 27% of Richmond's production workforce. The 3 Kaiser yards in the Pacific Northwest alone employed over 31,000 women by 1944. African-American workers numbered in the tens of thousands and were employed in skilled roles including welding, fitting, crane operation, and even supervisory positions. This level of workplace integration was highly unusual for America in the 1940s. The democratization of skilled labor at Kaiser enabled carried implications far beyond wartime ship production. By proving that complex manufacturing could be performed by trained workers rather than requiring generational craft mastery, Kaiser's shipyards challenged the most fundamental assumptions about labor, skill, and industrial organization. Christmas 1943 offered another powerful demonstration of the transformed industrial culture Kaiser had created. While traditional shipyards observed the holiday with 1 or 2 days off, Kaiser facilities maintained their production schedules. But instead of simply demanding continued labor, the organization acknowledged the sacrifices workers were making. At the Richmond yards, management arranged for Christmas dinners to be served in the cafeterias. Turkey, ham, and all the traditional accompaniments were provided free to workers on shift. Local churches sent carolers. The Richmond Municipal Band performed. Kaiser himself visited the yards, shook hands with workers, and personally thanked them for their service. By mid-1944, Kaiser's 7 shipyards had produced more than 800 Liberty ships, but his influence extended far beyond his own operations. The 18 American shipyards building Liberty ships had collectively produced around 2,400 vessels by that time. Victory ships, a larger and faster design that supplemented Liberty ship production from 1944 onward, were built using the same prefabrication and welding techniques. Total American maritime production between 1941 and 1945 exceeded 5,500 vessels, representing approximately 53 million tons of shipping. The scale of this achievement stunned contemporary observers and remains impressive even by modern standards. Commander Joseph Kenworthy of the Royal Navy, who was assigned to the British Admiralty delegation in Washington, watched American production with a mixture of admiration and envy. His official reports to the Admiralty declassified in the 1980s. These reports captured the British view of America's sudden industrial dominance. The United States, they noted, was building merchant shipping at a rate that exceeded the combined capacity of the rest of the world. Kaiser alone was producing more tonnage each month than the entire British shipbuilding industry. By Admiralty standards, the methods were crude. The ships were inelegant, but they floated, they carried cargo, and there were thousands of them. The Royal Navy built the finest warships in the world using traditional craftsmanship that required years for each vessel. The Americans built adequate ships in weeks. Adequate multiplied by thousands, they concluded, defeated perfection multiplied by dozens. Yet, perhaps the most remarkable part of Kaiser's transformation was what happened after the war ended. Traditional analysts had expected the wartime shipbuilding boom to collapse completely, leaving tens of thousands of workers unemployed and hundreds of expensive facilities abandoned. In part, that prediction came true. Liberty ship production ended in September 1945. By December, Kaiser's workforce had dropped from nearly 200,000 to fewer than 20,000. The Richmond shipyards, which had employed more than 100,000 workers at their peak, stood largely empty by the spring of 1946. But the knowledge created during the emergency program did not vanish. The prefabrication methods, welding techniques, and parallel assembly systems that Kaiser pioneered became standard practices in shipbuilding around the world. When Japan and South Korea rebuilt their maritime industries in the 1950s and 1960s, they carefully studied the Liberty ship program and adopted Kaiser's methods as a foundation of their own shipyards. The enormous shipbuilding complexes in Ulsan, South Korea, and in Nagasaki, Japan, which would dominate global shipping construction for decades, were direct descendants of the revolutionary practices first proven at Richmond. John Bunker, professor of maritime history at the State University of New York Maritime College, summarized Kaiser's lasting impact in his definitive study published in 1972. He wrote that Kaiser entered shipbuilding as an outsider, ignorant of maritime tradition, unconstrained by conventional wisdom, and willing to apply manufacturing principles that the established industry considered inappropriate for ship construction. In just 36 months, Kaiser built more ships than had been constructed in America during the entire previous century. More importantly, he fundamentally changed how ships would be built worldwide for the rest of the 20th century. Modular construction, prefabrication, and welded assembly, all pioneered in Kaiser's yards, became universal standards. Every modern shipyard, whether building container vessels in Korea, oil tankers in Japan, or cruise ships in Europe, now uses approaches that can be traced directly back to the Liberty Ship program. The scale of Kaiser's achievement can be measured in statistics that reveal both the magnitude of the effort and its extraordinary success. Production records show that 2,710 Liberty ships were built across 18 American shipyards between 1941 and 1945, averaging 1.8 ships per day at peak output. Kaiser's 7 yards alone produced 1,490 ships, accounting for 27% of all American wartime merchant shipping constructed under maritime commission contracts. Construction time dropped from an average of 230 days for the first Liberty ships in 1941 to just 42 days by 1943, with the record-holding Robert E. Perry requiring only 4 days and 15 hours from keel laying to launch. Labor efficiency improved just as dramatically. The first Liberty ships required approximately 1.1 million worker hours to complete. By 1943, that figure had fallen to about 486,000 hours per ship. Kaiser's most efficient facilities, Richmond Yards numbers 2 and 3, reduced construction time even further, completing ships in as few as 350,000 worker hours by operating 3 continuous shifts around the clock and maximizing prefabrication. Cost efficiency followed the same pattern. The earliest Liberty ships cost roughly $1.75 to $2.0 million each. By 1943, costs had stabilized at about $1.8 million, despite rising wages and material prices, reflecting dramatic gains in productivity and learning curve effects. Each Liberty ship displays 14,245 tons when fully loaded and could carry 10,800 tons of cargo. A single vessel could transport 2,840 jeeps, 440 tanks, or 230 million rounds of ammunition in one voyage. Powered by triple expansion steam engines that were deliberately old-fashioned but dependable and easy to manufacture, the ships reached speeds of about 11 knots, which was sufficient for convoy operations. Training efficiency was equally remarkable. Kaiser schools trained workers for specific tasks in an average of 2 weeks. The fastest programs produced productive spot welders in just 10 days. More complex roles, such as crane operators or ship fitters, required 4 to 6 weeks of training. This stood in stark contrast to traditional maritime apprenticeships, which lasted 4 years for basic competency and as long as 10 years for master craftsman status. The fundamental difference was specialization versus comprehensive training. Traditional apprentices learned every aspect of shipbuilding. Kaiser's workers mastered narrow, repeatable tasks that they would perform hundreds or even thousands of times. The battle casualty rates of Liberty ships demonstrated their effectiveness despite early skepticism about rapid construction methods. Of the 2,710 Liberty ships built, approximately 200 were lost to enemy action, a loss rate of about 7.4%. This compared favorably with pre-war merchant shipping losses and proved that welded construction, though once doubted, produced seaworthy vessels. Some ships did suffer structural failures caused by welding defects. 3 Liberty ships broke completely in half due to brittle fracture, representing just 0.11% of total production. Nearly 1,500 instances of significant brittle fractures were recorded across the Liberty fleet, but catastrophic failures were rare. These problems led to improved welding procedures and better steel specifications, which largely eliminated the issue by 1944. Longevity statistics provided the ultimate validation of Kaiser's construction methods. Liberty ships, although they were designed as emergency vessels with an expected service life of only 5 years, Liberty ships proved to be astonishingly durable. Many remained in active service for decades after the war. The SS John W. Brown, built in 1942, is still operational today as a museum ship in Baltimore as of 2024, more than 80 years after her construction. The SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and famously participated in the 50th anniversary commemoration of D-Day in 1994, actually sailing to Normandy under her own power after half a century of existence. A third Liberty ship, the SS Hellas Liberty, serves as a static museum ship in Greece. The post-war careers of Liberty ships extended far beyond anything their designers had imagined. Of the approximately 2,510 Liberty ships that survived the war, about 835 remained in commercial service through the 1960s. Many were sold to foreign shipping companies and continued operating into the 1970s. The SS Albert M. Bow, the last Liberty ship built and delivered on October 30th, 1945, was not scrapped. Instead, it was converted. Sold in 1964 for just $65,557, it became the fish cannery ship Star of Kodiak in 1965, and today remains as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska, still in existence more than 8 decades after it was built. The economic impact of the Liberty ship program spread across the entire American industrial landscape. The enormous demand for steel drove rapid expansion of production capacity, especially on the West Coast, where Kaiser constructed the Fontana Steel Mill specifically to supply his shipyards. Completed in 1942, 5 months ahead of schedule, the mill produced roughly 700,000 tons of steel per year and established California as a major steel-producing region for the first time. The magnesium required for incendiary bombs and the aluminum needed for aircraft were produced in Kaiser facilities built to support the fully integrated war production effort. Employment effects rippled through communities across California, Oregon, and Washington. The city of Richmond, California, grew from a population of 23,000 in 1940 to more than 100,000 by 1943, driven almost entirely by shipyard employment. In Oregon, Kaiser built Vanport City, which briefly became the state's second-largest city, with a population exceeding 40,000, all of whom worked in shipyards or related industries. These boom towns, though temporary, demonstrated the transformative power of concentrated industrial investment. Healthcare innovation emerged as an unexpected legacy of Kaiser's shipbuilding empire. To provide medical care for his massive workforce, Kaiser partnered with physician Sidney Garfield to establish prepaid healthcare programs. These efforts eventually evolved into Kaiser Permanente, one of the largest health maintenance organizations in the United States. The model of prepaid, preventive healthcare pioneered in the shipyards reshaped American medical practice for decades and served more than 12 million members by the early 21st century. The workers themselves carried the lessons of wartime industry into decades of peacetime achievement. The shipyards gave thousands of young people, especially women and minorities, opportunities to develop skills they would never have access through traditional career paths. Those opportunities opened doors that remained open for the rest of their lives. The technological innovations of the Liberty Ship program influenced industries far beyond maritime construction. Welding techniques refined under wartime pressure became standard in structural steel fabrication, petroleum refinery equipment manufacturing, and pressure vessel production. Prefabrication methods pioneered at Richmond reshaped construction practices in housing, bridge building, and industrial facilities. Organizational principles such as parallel production, simplified specifications, and rapid worker training became foundational concepts in operations management and industrial engineering. In a 1985 study on American industrial competitiveness, Professor Michael Porter of Harvard Business School identified the Liberty Ship program as a critical case study in rapid capability development. Kaiser demonstrated that industrial capacity was not fixed, but could be created quickly when necessity demanded it. The United States entered World War II with minimal merchant shipbuilding capability. Within 24 months, American yards were producing more tonnage than the rest of the world combined. This proved that industrial infrastructure, workforce skills, and production systems could all be developed at unprecedented speed when properly organized. That lesson extended beyond wartime emergency. It suggested that perceived limits on industrial capacity often reflected organizational and conceptual constraints rather than physical impossibilities. The psychological transformation created by the Liberty Ship program among engineers and industrial managers was as significant as the ships themselves. Before Kaiser, manufacturing leaders accepted conventional wisdom about production limits, skill requirements, and organizational structures. Kaiser showed that conventional wisdom could be wrong, and that breakthrough performance required questioning fundamental assumptions. The Liberty Ship story ultimately stands as a testament to a deeper truth about human potential and industrial possibility. The ships themselves, though vital to Allied victory, mattered less than what their construction proved. Ordinary people, given training and opportunity, could achieve extraordinary results. Products once thought to require years of specialized craftsmanship could be manufactured in weeks through systematized processes. Industries that had resisted change for centuries could be transformed in months when urgency and innovation combined. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the strategic impact of American maritime production in his post-war memoir published in 1960. He wrote that the war had been fought across 5,000 miles of Pacific Ocean, supplied by ships built faster than the enemy could sink them. Japan's military planners, he said, assumed American industrial capacity was impressive but finite. They believed that if they destroyed enough ships, American logistics would eventually collapse and force negotiation. They failed to account for Henry Kaiser. By 1944, American industry was replacing shipping. Losses were being replaced faster than the enemy could inflict them. The mathematics of attrition now favored the side that could build 3 ships a day over the side that could sink 2 ships a day. Industrial capacity, not martial valor, determined the outcome. The Pacific War was won in the shipyards of Richmond, Portland, and Baltimore just as surely as it was on the beaches of Iwo Jima and Okinawa. In the end, Kaiser's greatest achievement was not the 1,490 ships his own yards produced, but the transformation of what entire industries believed was possible. The SSRobertEPerry, built in less than 5 days, stood as undeniable proof that tradition did not equal truth, that conventional wisdom could be questioned, and that revolutionary improvement required revolutionary methods. The maritime establishment that had dismissed Kaiser as an ignorant outsider in 1940 would spend decades after 1945 studying and implementing his techniques. The young workers who learned to weld, fit, and fabricate in those emergency shipyards carried both their skills and their confidence into peacetime careers that helped rebuild America's post-war economy. The methods pioneered under the pressure of wartime necessity became peacetime standards that reshaped manufacturing across industries and around the world. The story of how one civilian's unconventional approach made Liberty ships appear in days instead of months is ultimately a story of transformation through demonstration. It shows that the greatest revolutions often come from those unconstrained by tradition, that progress demands questioning accepted limits, and that human potential far exceeds conventional expectations when properly organized and challenged. Kaiser's workers were not extraordinary people. They were ordinary people achieving extraordinary results because someone believed they could and created systems that allowed them to prove it. That lesson, demonstrated in the shipyards of Richmond and validated by 2,710 completed vessels, remains relevant wherever industries confront challenges that conventional wisdom declares impossible. Most of the Liberty ships are gone now, scrapped decade ago or resting on the ocean floor. But the revolution they represented still lives on in every modern shipyard, in every manufacturing facility that uses prefabrication, in every training program that teaches precise skills quickly instead of broad expertise slowly, and in every manager who asks whether impossible truly means impossible or simply means that no one has yet discovered how. This is Henry Kaiser's enduring legacy, carved not in steel, but in a transformed understanding of what determined people can achieve when freed from the constraints of tradition and challenged to attempt what experts insist cannot be done. From December 1940, when he signed his first contract knowing nothing about shipbuilding, to November 1942, when the Robert E. Perry was launched after less than 5 days of construction, and to September 1945, when the final Liberty ship was delivered, Kaiser proved that industrial revolutions do not arise from incremental change, but from a fundamental reimagining of what is possible. The 2,710 Liberty ships built between 1941 and 1945 carried more than cargo across the oceans. They carried proof that human ingenuity, when released from tradition and empowered by necessity, can accomplish what once seemed impossible.